Okay, so normally we'll get this kind of races in asynchronous sequential circuit when two or more binary state variables changes values in response to a change in a input variable. 0 0 1 1, right? Now look at here. Now we are discussing about race. Okay, race. In that first type of race is critical race. When this critical race will happen? While changing from 0 0 to 1 1. Suppose our intention is to change from here to here, but first it may go to 0 1. After that, look at here. Here possible transitions are mentioned, right? In this slide possible transitions are mentioned. What are all those possible transitions? It may go to our intention is to change from 0 0 to 1 1, right? But the intermediate transitions, first it may go to 0 1, after that it may go to 1 0, right? So these are all some possible transitions, but these transitions also based on the order.
Yes.
Order in the sense that 0 0
0 0 0 1 1 0 1 1.
0 1, yeah. Next, the second type of race is non-critical race. Look at here. If the final stable state that the circuit reaches does not depend on the order in which the state variable changes, that kind of race is called non-critical. Yes, right. Next, we have to see how to avoid this kind of races. Okay, race-free binary assignment to the state variables. Okay, so if you look at the methods to avoid these races, the first method is the binary assignment. We know state encoding and all, right? State encoding style. What are all the different types of state encoding?
Binary state
Right.
encoding.
Okay, then
Gray coding.
gray encoding. Okay,
Then
one
one
not,
photon coding.
one cold. So
One
these are all
cold.
the many different kinds of state encoding styles, right?
Yes.
Okay. Now look at here. Here one note is there. What is that? Cycle. When a circuit goes through a unique sequence of unstable states, it is said to be cycle. What is it? Yeah. The definition for cycle. Here afterwards we are going to use the cycle. Okay. The cycle. The definition for cycle. When a circuit goes through a unique sequence of unstable states, it is said to be a cycle. Now, what is static hazards? Look at here. Static 1 hazard. Static 1 hazard means the output should be 1 but goes momentarily to 0 as a result of an input change. Okay, look at here. We want the stable output. If you look at this diagram, you will get in the first diagram we are expecting the stable one, but momentarily it's go down and again it come back, right? So this kind of glitch is known as static 1 hazard, right? We are expecting the stable high, but momentarily you are getting that glitch, output glitch, due to the changes in the input. So this kind of hazard is known as static hazard. Next, what is that? Static 0 hazard. That is just opposite to this static 1 hazard. What is that? We are expecting 0, logic 0, but momentarily your output goes to high. That is again come back, right? It's a small pulse kind of thing. Okay, and if you note this slide here, I mentioned where in what kind of situation we will get the static 1 hazard. It is possible in AND OR gate. Static 1 hazard is possible in AND OR combination. In first level you are having AND gate, in the second level you are having OR gate. That case you will get, there are chances to get this static hazard 1. If OR AND, in that kind of circuit it's possible to get static 0 hazard. Next, look at this example. So far we have discussed about static hazards. Okay, static hazard. In static hazard we have changed only one momentarily change, right? Momentary change. But dynamic hazard means if the output changes more than once. Okay, then that kind of due to the result of changes in input. then that kind of dynamic hazard is known as dynamic hazard. Okay, so dynamic hazard occur in multi-level circuits. Getting? So if you look at this figure, it's very clear, right? Here actually we want to have the logic high, but it's momentarily go and again come back. This kind of transition is known as dynamic hazard. Look at here. Okay, so in that previous slide they mentioned that where we will get dynamic hazards in multi-level circuit, right? So look at here, this is in this circuit how many levels are there? 1 4 level circuit. Okay, so this is the timing diagram explanation for this diagram. Okay, look at here, x1, x2, okay, x3 and x4. Now each NAND gate will have its own delay, right? Okay, now at time t is equal to 0, x1 is high. Okay, what about x2, x3, x4 all are 0. Suppose I am keeping it like this. Okay, now this x1 is having the long delay, right? X1 has to travel this gate, then this gate, it has to travel the all the 4 levels, right? But what about x3, sorry x4? It has to travel how many levels? 2 levels. Okay, so due to that, you look at here, this is the F. Okay, momentary transition, right? So this kind of hazard is known as dynamic hazard. Getting? So how to prevent this kind of dynamic hazard? In the case of static hazard, what we did, we simply added redundant terms. But in the case of dynamic hazard, how you will avoid? Yeah, some points here. Look at here. Use 2-level circuit instead of using multi-level circuit.